right, so chapter 11, we're still going to be dealing with logs and exponents, but now we're actually going to be using them a little bit more as far as like solving. All right, so here we go, doing logarithmic equations, what we're going to be solving. Remember, an equation's got to have an equal sign with it. That's going to be one of the main differences here. This is just from old being able to convert from logarithmic to exponential and vice versa. All right. So this chart in the beginning, you're just again reviewing how to switch back and forth. The way that I like to do this is I like to go this times this gets me back to here. And that's what you should be doing for each one of these. And so remember, this is always going to be the base. This is called the argument, and that is called the exponent. So you should just be familiar with how to switch all these back and forth. It doesn't matter if it's a fraction or anything like that. Like, this can still be a base. Notice it's still down there. The exponent, everything's still the same. E, remember, if I do E, it's not going to be log. It's going to be ln. And then, like right here, this question is really asking 6 to what power is 36, and we're going to learn how to solve that kind of stuff. So that's just basic going back. So here we go. So this one, it asks you to arrange them. Again, you should pause maybe the video, look away, and try to do some of these. We'll do A together, and then maybe you should try B and D or something like that. But remember, if there's some hints here, right? If it's going to be 49, I know that I can do 7 to the second power equals 49. And then I can change that to logarithmic form. Since this is the base, that's a 7, even though it's hard to see. That's going to be the 2 equals the 49. Right here, since I have a negative, it's probably going to be in a fraction. I probably know that this is going to be the exponent, and this is going to be the answer. 4 to the first power equals 1, right? 4 to the fourth isn't going to be, that's going to be way bigger. 1 to the fourth is going to be 1. So, you know, you're just kind of playing with this. I'm looking at that. All right. So this is where we actually get to solve these guys. If you have a question like this, where you have the argument is known, remember, or is the unknown. The argument is what it really equals in exponential form. So what they did is they said, oh, if I want to know this, I can just switch it to exponential form, and then I can actually just do 4 times 4 times 4, which is 64, and I can solve for y that way. When my exponent is the unknown, what I have to do is I have to break down this 64. What has to happen? If I have 2 to the third, and I say that's going to equal 2 to the x. Once I get this base to be the same, I know that this has to be the same as that. So x would have to equal 3, right? Because 2 to the third power is only going to equal 2 to the third power. Well, the problem lies when we get a problem like this. And I've got 4x, and that's my base is 4, and I've got 64. The problem is that's not the same base. I can't say, oh, this is the first power, so x equals 1. No. Because this is a 4 and this is 64. So what I do with my base is I try to rewrite that so that it has the same base as this one. And sometimes I need to change this base, and sometimes I need to change this base, and sometimes I have to change both of them. And so that's what we're going to be going through. This section is learning how we can change those so that I can get 4 in the 4. So what they did is they break down 64. And when you break down 64, you realize that you can write it in terms of 4, and it's 4 to the third power. Again, if you broke it down, it'd probably give you groups of 2, but you should realize that it's really 2. You know what? That might work. Let's try it like that. The way I would probably solve this is I would actually make these both become 2, base 2. We'll just leave it like that. So I want to make it become 4, so what I do is I try to see how many times 4 times 4 times 4 is 64, and that's where they get 3, because it's 4 to the third is 64. So then if I have 4 to the x equals 4 to the third, then I know x has to be 3. We'll talk about some of the other situations a little bit later on. This is just a basic knowledge. And what if my base is unknown? The b is right here. That's my unknown. So then I change it, and I want to know some number to the third power equals 64. Well, we've been dealing with this. Hopefully you realize that, oh, wait, this is 4 to the third. So if I have, if I had b to the fifth, and that's supposed to equal 7 to the fifth, then I should know that the only thing raised to the fifth power that's going to be equal to 7 to the fifth is if I have 7 to the fifth over here. So b is 7. That's kind of all they're trying to show you here. All right, so some more examples. You might want to try to stop the video and solve them on your own here, and I'll just talk through them. But right here, you can rewrite this 64 as 8 squared, and so I changed this to log, from log to exponential form, and it became, that's at 8 as the base, so 8n equals 8 to the second, and hopefully you can see that n has to equal 2. With these right here, again, you change from log to exponential form. Your base is not the same. So what they did is they go, wait, how can I rewrite 16? This is, you're going to have some thought process in your head. How can I rewrite 16? I want it with a base where it's something to the negative 2 power. So if I can rewrite that as 1 over 4 to the second. Well, if it's down here, notice we talked about if you have 4 to the negative 2, that really equals 4 over 4 to the second. The negative says, hey, go down to the bottom. Well, what happens if I have a 4 to the 2 in the bottom, but I want to bring it up? Well, kind of doing the opposite this way, if I can send it down, I can bring it back up by putting a negative in the exponent. And so what they did is they wrote that as 4 to the negative 2 power. And then once I have both of those, I have n to the negative 2, and I have 4 to the negative 2. That means that n, my base, or my base would have to be 4. All right, just going through some more of these questions. For this one, they take a half, and it's going to be half to the nth power is 64. So what they need to do is we need to change this 2 around. And so how can I change that 2 to be a half is, let me zoom out a little bit more, is if this right here is 2, how can I send it down to a denominator is if I make it 2 over to the negative 6. And then what they do is they say, hey, really what this can be is even if I have negative 6 here, they both can have that. Then they pull that out. They kind of undistribute it, pull it out to the top, and it becomes negative 6 up there. And then I have half to the nth has to equal half to the negative 6. I know that n's would have to be negative 6. Again, you have to practice this a little bit. Right here, all they do is, since they know, remember this is natural, or this is going to be my common log, common log, which means just one we use commonly. And it's a base 10, so 10 to the negative third equals n. And then they actually just take 10 to the negative third. That sends it down to the denominator, so I have 1 over 10 to the third. When you do 10 to the third, you get 1,000. And as a decimal, it would be that. I would accept this answer also, just so you know. All right, right here, they are going to take this. Remember, if I want this as 2, this is n to the 2 thirds, and this equals this. I need it to have something to a power, right? So I need to figure out what the base is. So the way I'm going to do this, I need to change. They say, this is from, I think, chapter 8, where they change the radical form into power form. But the problem is, this is 2 thirds here, and this is 1 third. So what they do is they say, hey, you know what? We can break down 49 into 7 squared. And when you break it down to 7 squared, what happens when you do a power to a power? You multiply the 2. Remember, if I had x to the second raised to the third, that gets me x to the 6. Why? Because I multiplied these two guys. So right here, when they have 7 to the second power raised to the 1/3, they multiply 2 times the third, and that's how they get 7 to the 2/3. Once I get, so see, your goal is, I need something to the 2/3 power. So what they're doing is they're manipulating this guy until they can get it raised to the 2/3 power, and they're changing it to exponential form. Then they're changing this. They're breaking this 49 down to 7 squared, and then they multiply these two together, and then they say, oh, it's 7 to the 2/3. So then my n has to be 7. I hope that's kind of helping you understand this. Here are 3 expressions that are equivalent to the given. So all you're looking here is, this really means 5 to some power equals 625. And when I do that, I realize that it is 5 to the 4th power. So x equals 4. So all I need to do is make anything that is equivalent to that. So right here, this is saying that if you take log base 2 raised to 6 with the argument of 16, that means 2 to what power equals 16? The answer again is 4 here. So all you have to do is make sure all these is 3 to the 4th is 91. 4 to the 4th is 256. So that's all you're looking for in these questions. All right, we answered the next question. So then the last thing that we should be able to do fairly quickly, all they're doing is changing it with different negatives and stuff. You could pause the video to look at that. Then what they're doing next in problem 2 is just showing some approximations. And so they put these guys on a number line, and the way that you know this is, remember, how do I know that this is here and this is here, is because 2 to what power equals 1/4. Well, that would mean I need this to go down to the denominator, so it'd be 1/2 2 to what power, and that became a negative x, so it'd be -2, right? Because 2 to the -2 power. So this is really the number -2. This is really the number -1. This is really 0. This is 1. And that's what this number line up here is showing you. So they're showing all these different formulas, because what happens is, if they want me to approximate a power, I can do that. So here we go. If they want me to approximate, say, hey, give me an estimate for where log 3 base, so log base 3, 33 is equal to, they said, well, wait, I know this right here is 3 to what power is 27, that answer would be 3, right? But wait, 3 to the 4th power is 81, so that's the 4. And this is, I know that 33 is in between 27 and 81, but it's closer, it's much closer to 27. I know that x is going to be between remember, this means 3 to what power equals 33. I know this x, this power, is going to be much closer to 3 than it is to 4, because the 33 is a lot closer to 27. So it is going to be between 3 and 4, but it's going to be much closer to the 27 side. And so all we have to do is, you notice that's what they did on this number line. They put it a lot closer to the 27. And to estimate for that, it would be 3.2. All right, so this person did a good job with theirs, because we know that it's going to fall between 4 to the second power is 16, 4 to the 3rd power is 64, 28 falls between those, and it's going to be much closer to the 16 than it is to the 64. So I know it's going to be somewhere around that. This is just to get you an estimate close to this. So there's another way that they do this. And so again, we'll have more practice on this when you come to class on Monday, and I'll talk you through some of the examples. All right, that's just to get us started.